And we know that when you look on the input-output analysis, we say that this is the technique. It is a technique. It is a technique that is used to study the flow. That is used to study the flow of input. That is used to study the flow of input in various sectors. In various sectors in an economy. In an economy. So it means that this technique is basically used to see what is the flow in various sectors in an economy. So it is based on the concept. It is based on the concept. That no sector in an economy, can operate. No sector in an economy can operate in isolation. So in most cases, we know that we have to be looking on the terms which are basically used. Terms used here. Number one, we normally start with intermediate demand. And when you look on the intermediate demand, we say this is the demand. This is the demand. This is the demand. This is the demand from within. From within. This is the demand from within. What is consumed? What is consumed by the producing? What is consumed by the producing sectors? What is produced by the producing sectors? Number two, we normally look on the final demand. Final demand. And when we look on the final demand, we say it is just a demand. It is a demand from non-producing sectors. It is a demand from non-producing sectors. Then later on, number three, we look on the total demand. We look on the total demand and you say it is a combination. It is a combination of intermediate demand and final demand. Now, number four, we normally look on the primary inputs. When you look on the primary input, we say they are inputs. They are inputs from non-producing sectors. These are the inputs from non-producing sectors. So what are types? The types that we normally have, types of inputs, output model. We normally have only two. One, we normally have open input-output model, right? And we say very well that open input-output model is a model where what is produced is a model where what is produced is consumed by the producing and non-producing sectors. non-producing sectors. That is what is being produced, is consumed by both producing and non-producing sectors. But number two, when you look on the closed input output model, we say there's a model where what is produced is consumed by the producing sectors alone. Now, it means that you have to be looking on what are the purposes of the input-output model, and later on, you will be able to see the assumptions of the input-output model. Those ones will be able to, or I will be able to share with you later. Now, I just want to look on the analysis of the input-output model, the analysis for input-output model. That look on the analysis of input-output model here. Analysis of input-output model. We want to look on the analysis, and when we look on this analysis, we have to be understanding that there are some of the assumptions where we see, we normally look on this aspect where we say all input in an economy emerges output. That is, the total input will be equal to the total output. So it means if you look in production in a production way, you can see that when we are talking about the total input, it means that the total input and the total output are equal. So what is being produced, what is being injected for production is what you get. There is no any losses which are going to be attained. So in this case, we say for the total input, we are going to be taking intermediate demand plus final demand. We're going to be having intermediate demand, and then we have final demand. So the total demand of viewers is going to be represented by X, which should be equal to XA plus D. In this case, you can see we have two X's here. Make X the subject. Make X the subject, and when you make the X the subject, it will be easier for you, since you're going to be having, you're just going to be bringing X on the other side. So it will be X minus XA, which should be equal to D. Then pull X outside, it will be 1 minus A, right? This is X here, should be equal to D. Divide here by 1 minus A, divide here by 1 minus A. Then that one goes. So our X should be equal to D over 1 minus A, or, right, or we can just be taking D, then you multiply by 1 minus A raised to a negative 1, there. Now, from that aspect, I just want us to define what is our D, and we know very well where D is equal to our final demand. D is our final demand. We also have 1 minus A. It is normally called Leontief. It is normally called Leontief matrix. But when we have 1 minus A, you raise to a negative 1, we talk about inverse. It is normally called inverse of Leontief matrix. Inverse of Leontief matrix. We also have to be looking on I, which we normally talk about identity matrix, right? Then we have our A, which is a technical coefficient matrix. It is your technical coefficient. We are talking about technical coefficient matrix. Then we have our X, which is our total output. Total output. That is the thing. It should be the total output or total input. Remember, we say the total under the assumption that I was able to quote for you. We say the total input or the total output are equal. I just want to do a question here, right? There is a question tested in May 2019, question 1. 2019 here. There was a question for input output. We're talking about May 2019. It should be question number 1C. Question 1C. Right? Question 1C. So let us go to that question there. Question 1. Let me, it should be November somewhere. Let me see. We look for November. It is November. You can read for me, please.
November
2019, question C, 1C.
A small economy has two sectors, X1 and X2, producing a single product for their internal and external demand in units, as summarized in the following transactions matrix. We have production sector, X1, X2. We have purchase sector, X1 at 500, X2 600. We have 800, 1400. We have consumer demand, 200, 400. The projected consumer demand changes to 400 units and 800 units for sector X1 and X2 respectively. The required gross output of each sector in order to meet the new demand.
Good. The question is already given there. So it means until they have given you the consumer demand. So the only thing that I have to be doing is calculation of the technical coefficient matrix. That is where I'm going to be starting my question from. From that aspect, I'll be able to proceed following the input-output model of ours until I will be able to get the gross output required for each sector. Now, from that aspect, let us go back to our board and we say, this is what you do. I just copy the question the way it is. So in this case, I'm talking about, I can see here, we have X1, we have X2, right? And also here we have X1, we have X2 here. Now, for X1, I can see it is 500, 600. Here we have 600, right? Then the other one is 800. 1400. We have our demand here, which is the consumer demand. Sometimes it is, the examiner was able to give you the final demand, which is equivalent to 200 and 400, right? Then calculate your total demand here. Your total demand you just need to add. So when you look at it, the first one should be 1500. The second one should be 18,400. Right? So if, for example, I'm calculating my technical coefficient matrix, so it means here, the total for this one is 24. The total for these is 1500. So when you're calculating your matrix, you just take 500 So that is what you do, right? That is what you do. Now, in our case here, you just need to multiply. Now, the first one is 500 divided by 1500. Here, I'm getting 0.33. The second one will be 600 divided by 1500, getting 0.4. The other one will be 800 divided by 2400, getting also 0.33. Then the other one is 1400. You divide by 2400, and we are getting 0.58. 0.58, like that. Now from there, we need first to be getting the determinant of our matrix. You see these are 2 by 2 matrix. And we say to get our determinant, you need to be taking the product of the primary diagonal minus the product of secondary diagonal, right? Now from that, we just need to say 0.33 times 0.58 minus 0.4 times 0.33. So what is your determinant here? So 0.33 times 0.58 minus 0.4 times 0.33. We are getting 0.0594. That is what we are getting as your determinant. Then from there, let us do an inverse of this matrix of ours. So to get the inverse definition, we said the primary diagonals changing the sign, changing the positions, while the second diagonal changing the sign. So it will be 0.58. And then up we have 0.33. Then here we have negative 0.4. Here we have 0.33 negative. It will be similar like that. Then we say multiply it with 1 over determinant, 1 over 0.0594. Right? So this is a scalar matrix, you know that. So in this case, let's just first open these brackets by multiplying by your 1 over determinant. So I just need to say 0.58 divided by my answer here, and I'm getting 9.76. Then negative 0.4, you divide by 0.0594. We are getting negative 6.73. Then the other one will be negative 0.33. You divide by 0.0594. And we are getting negative 5.56. Then the last one will be 0.33 times, divided by 0.0594. We're getting the same now. This will be 5.56. Right? That is what you are able to do. Then remember, the examiner is telling you the projected consumer demand changes to 400 and 800 units. Remember, this now is the initial stage. So to determine your next stage, for instance, because you're borrowing that knowledge there, right? So in this case, we have been told we have 9.76. 9.76. We have negative 6.73, negative 5.56, right? We have 5.56. This is what we have right now. But we are being told by your examiner that it was able to change to 400 and 800. Right? So let us multiply these two matrices. So you multiply the row with your column. So to get for x1, because already you know this is x1 and this is x2. So to get for x1, we are going to be taking 400 times 9.76 plus 800 minus times minus 6.73. That one we're going to be getting there. Then for x2, we are going to be getting 400 times negative 5.56 plus 800 times 5.56. So how much are we getting here? So 400 times 9.76 plus 800 times negative 6.73. Let me look at it again. So it will be 800 times negative 6.73. Right, then we have 400 times 9.76 minus 5384. Okay, we are getting negative 1480. Then the second one will be 400 times negative 5.56 plus 800 times 5.56. We are getting 2224. We are getting 2224. 2224. That is what we just do. That is how simple input-output is. I will be able to share with you a certain question. You do a revision so that I can see whether you can be able to understand the concept. Now, from there, I just want to do something different. Just want to do something different now. This something different we are doing. I just want to do set theory. Let us do our set theory now. Set theory, which is one of the targets. Examiner is targeting it so much. So when you look on the set theories, now we normally talk about a set theory being a collection of elements. Is a collection of elements with similar characteristics. So it is a collection of elements with similar characteristics, and we are saying that these items must be having unique attributes. These items must be having unique attributes. It must be having a unique attributes. And in this case, when you look on it, it means that which is only common to the members of that group, which is mostly common to the members of that group. For instance, when you look on the combinations, you can talk about doctors. You know, these are the people with similar characteristics. You can talk about accountants. These are the people with similar characteristics, right? So already you know that is your set. We have doctors, which already we know we have similar characteristics. We have accountants, and you can talk about lawyers, right? You cannot say this lawyer is more superior than the other, right? They all learn the same thing. They all have similar characteristics. The types of sets, you know very well. There are very many, but I just want to list them down here. Types of sets. Types of sets which we are going to be using. Number one, we normally have universal sets. When you talk about the universal set, we normally look on a set. This is a set which contains. It is a set which contains all the elements of a given population. That is why we are discussing about all the elements. That is a universal set. Number two, we normally talk about subsets. And in this case, when you discuss about the subset, it is very simple because we say it is a set which contains some elements It is a set which contains some elements. It contains some elements. It is a set which contains some elements which are also contained in a universal set. So to discuss about a universal set, for instance, let us have our universal set having 1, 2, 3, 4, and 5. Then the subset of these, for instance, we can talk about, let us talk about set A having 2, 3, and 4. So in this scenario, you can say A is a subset. A is a subset. A is a subset because you can see it has some elements which are containing in the universal set. Number 3, we normally have null sets. And when you look on the null set, it is a set that does not contain any element in it. It does not contain anything. A minute, please.
Okay.
Now we were discussing about a null set, and we have said it is a set that does not contain any element in it. Another type of a set, we look on the finite set, number 4. Finite set, and we say it is a set which contains elements which can be listed down, But when you look on number 5 here, we talk about infinite sets. When you look on the infinite sets, we say it is a set which contains elements which cannot or which can be listed down. Elements which can be listed down. So that is the infinite set. Now we normally have disjoint sets. Number 6, we talk about disjoint sets. And when you look on the disjoint set, we say these are sets which do not contain. These are sets which do not contain common elements. It does not contain common elements. For instance, you can be having set A which has 1, 2, 3, and 4. Then we have set B which is having A, B, C, and D. You see, these are disjoint sets. Then we have the other one, which we are talking about equivalent sets here. So we look on the equivalent sets. Look here on equivalent set number 7. You look on the equivalent sets and we say these are the sets with the same number of elements. Is a set with the same number of elements. They have the same number of elements. So the same number of elements, This is the set with the same number of elements. So in this case, remember you might be having set A, which is having 1, 2, 3, and 4. And then we have set B, which is having A, B, C, D. You say it is an equivalent because they have the same number. They have for 4, the same number of elements, right? Good. Now, in this case, we have equal sets. equal sets. Now the equivalent set should be even be having 1, 2, 3, 4. Because now when we go to number 8, we discuss about equal sets. Equal sets, and you see these are the sets with they are the set with the same number of elements. They are the same, they normally have the same number of elements. If it is 4, it is 4. Then we go to number 9, where we discuss about unit sets. And we say this is just a set with only one element. There is a set with only one element. It is a set with only one element. With only one element. So I just want to look on the set operations so that we can move quickly. Set operations here. I'll be able to do 2 questions here. And then you will be able to do others as assignments. So we have set operations. We have set operations. Eunice, there is a class I'm attending. I just want you to excuse me a minute. We are presenting something. Now we can resume. The set operations, we normally look on number 1, where we have union of sets. Union of sets. 2, we normally look on set complement. Set complement. We normally have number 3, where we look on the set intersection. And then we have number 4, where we normally discuss about set difference. Now, this is very simple, since the examiner here, when you see the issues of the union of set, the examiner uses OR. The issues of set intersection, examiner uses AND. So every time you see examiner using OR, it means it is a set, it is a union of sets. And then when you see the set intersection, it means the examiner is using AND. So I want to start with number 1, union of sets. Union of sets. Now, when you look on the union of sets, we are saying that it is a combination. This is a combination. It is a combination, right? It is a combination of 2 or more sets. It is a combination of 2 or more sets. It is a combination of 2 or more sets. And in this case, we are saying the union of set A and B, the union of set A and set B, the union of set A and set B, right, means all the elements, it means all the elements that belong to A and B. That belong A and B. And in this case, or both. Let me use that one. And both, or both. Now, in this case, for instance, a set normally looks like this, right? So a set normally looks like this. So this is set A, for instance, and this is set B. So when you discuss about the union, it means you have to be taking the elements of this both. So it normally looks like this. So the shaded region gives us the union of, it gives the union of sets. That is okay. The shaded region gives the union of set A and B. Now, I just want us to look on the set complements, right? Let us look on the set complements. We look on set complements. We look on the set complements. And when you look on the set complement, we say, if set A, right, is a subset in a universal set, is a subset in a universal set, then the complement of then the complement of A are those elements that do not belong to A but are found in a universal set. They are found in a universal set. And in this case, let us look on your universal set. You have A, B, C, D, E, F, G, and H, right? That is what you have. And in this case, you find that A is having A, B, C, and D. So when you look on A complement, it means the elements which are in universal, but they don't belong to A. And these elements we have E, F, G, and H. E, F, G, and H. That is what the set complement is all about. From there, I just want to look on set intersections. And set intersections is what two sets are sharing, right? So set intersection, it normally looks like this. Set intersection. It normally looks like this. So you have two elements here. We have, this is set A, for instance, and then we have set B here. Right? So it normally looks like this. So we have the shaded region here. So this shaded region is what we talk about set intersection. The shaded region, what they are sharing, and that is where you see the examiner normally discusses about it normally uses the word and, meaning what the two sets are sharing. Now, after that, we look on the set difference. The set difference, when you look on the set difference, it normally looks like this. Now, the set difference is what belongs to you only. Set difference. Set difference. What belongs to you? For instance, this is the difference between two sets. It is the difference between two sets or more. Two or more sets. Now, in this case, we are saying that when you look on the set difference, for example, our universal set, our set that we have in here, when you shade, for instance, this side, it means what belongs to me. So in this case, for instance, we say, right, we say, this is what, this is what belongs to set A only. Set A only. What belongs to you? That is what we are discussing about set difference. I just want to look on two illustrations. One, I just want to look whether last semester they were able to test. Last semester, whether they were able to test set theory. So August 2022. August 2022. So let me go there to the questions. Let's go to 2022. So we are looking for August. So where is QA, quantitative analysis here? This is an area where the examiner keeps on checking whether the students are understanding these criteria. And the question is here. It is question 5B. You can read, please.
A survey of 850 residents of a certain town aim at finding out the brand of vehicle owned produced the following result. 316 resident own Nissan vehicle, 160 resident own Honda vehicles, 360 resident own Toyota vehicles, 120 residents own both Nissan and Toyota vehicles, 56 residents own both Nissan and Honda vehicles. 80 residents own both Honda and Toyota vehicles. 240 residents did not own any of the three brands of vehicle required. Present the above information in the form of a Venn diagram. 2. The number of residents who own all the three brands of vehicle. 3. The number of residents who own just one of the three brands of vehicles.
Now, this concept is very simple. The first thing that we have is to present this information in a Venn diagram. And this is what you normally do without struggling. So you normally come here, right? Normally come here. You see, we are dealing with three types of vehicles. We have Nissan, Honda, and Toyota. So we draw our Venn diagram and interlocking it. Look at it here. So it looks like this. So I interlock. So, but I follow the information the way they are, how the information is. Here we are discussing about Nissan, right? Then we have Honda here. And then we have Toyota. So it looks like this. Right? It looks like this. It looks like that. Then let us rename the empty spaces, right? Remember the analysis that you are doing. That is what we talk about universal sets, which is equivalent to 850 residents. 850 residents, right? So I just want to name my empty spaces to ensure that I get the required questions. So here we have our A, this is B, this is C, this is our D, E, F, G, and H. Without even starting analyzing that question, just come and you say A plus B plus C plus D plus E plus F plus G plus H should be equal to 850. Right? Now, in this case, we just say, when I get these values, I will be putting them here. And in this case, the totals, we are going to be getting them down there. Going to be getting those totals down there. Now, when you look on this scenario here, it means I have now to be getting the information provided by the examiner. Number one, the examiner is saying 316 residents owned Nissan vehicles. So when I look on the circle of a Nissan vehicle, the elements which are already contained there, we have A plus B plus D plus E. Those are the elements which are contained in the Nissan. Now, I know that you are contemplating, why are we not factoring A only? It means the A only, the examiner has not used only. That is where you see we are factoring the Nissan, the circle for the Nissan. You see A, B, E, and D are all contained there. And this is equivalent to 316, right? 316. The second one we have Honda. When you look on the Honda, the examiner is saying 160 residents owned older vehicles, and it is, in this case, we have B plus C plus E plus F. And the examiner is giving us 160, right? 160. Then we are being told that 360 residents own Toyota. They own Toyota. And in this case, when I look on my circle for Toyota, we have D plus E plus F plus G, which is equivalent to 360. That is the information provided there. But we are being told very well, 120 residents own both Nissan and Toyota vehicles. Nissan and. You see, when we discussed about and, we said it means intersection, what they are sharing. And when I look at it, where we are discussing about Nissan and Toyota, what are they sharing? They are sharing D and E. You see these circles, the Nissan and Toyota, they are sharing D plus E, which is equivalent to, or which is equitable to 120. Then we have 56 residents on both Nissan and Honda vehicles, Nissan and Honda. So what are they sharing? We are discussing about B plus E, which is equivalent to 56, which is equal to 56. Then from there, we are being told 80 residents on both Honda and Toyota. Honda and Toyota, you see what they are sharing, it is E and F. A plus F, it is equal to 80, right? Very good. Then the other one we are being told, 240 residents did not own any of the three brands of the vehicles. And that it means the examiner has already given you H. H does not own any vehicle, and that is equivalent to 240. That is 240. Right? Because the resident did not participate in any, so it means does not own any. H does not participate, whether does not own. Now, in this case, we just need to be simplifying our equations here, because already I can see if, for instance, we can start with the first equation here, because we want to simplify it. Let us get the value of A and B, because you have D and E. Our D and E is 120. So we say A plus B should be equal to 316 minus 120. 316 minus 120. How much are we getting here? So let me see. So we are talking about 316 minus 120. We are getting 160. 196, sorry. So already in my main chart, I know this plus this one is 160. Right? Then I have my D and E. My D and E, I know very well, it is 120. Right? It's 120 there. Then it means your H, you know, it's 240. Then we talk about FG. I can see FG, I can get the value here because we have D and E. So you say to get F plus D, we just need to take 360 minus 120, which you are getting 240. Right? Let me see. 360 minus 120, yes, 240. So you just tell me here, this is equal to 240. 240. The question that we're supposed to be asking, let us unlock our equations by looking for the value of C, right? How can I get the value of C? I will be able to take 850 minus all of these. So it is 850 minus 160, right? Minus 120 minus 240 minus 240. And the value of C here is 90. The value of C there is 90. Now, from there, I just need to be looking on the areas where we have C, right? I can see here we have C. So it means our C here is 90. Our C there is 90, right? Our C there is 90. Then we have the value of A and F. Our A and F is 80. No, we are getting it wrong.
Excuse me.
Yes, yes.
So I think A plus B should be 196.
Yes, that is why I'm saying we are getting it wrong. Thank you. So 196. This one is wrong. So let us repeat our C. So it will be 850 minus 196 minus 120 minus 240 minus 240. We are getting 54. We are getting 54. So if this is 54, and thank you for correction, then it means because the value of A and F, which is equal to A and F, it is 80. So what is our B? What is our B? And in this case, our B should be, right, 160. 160 minus 54, right, minus 80. So in this case, we know our B is 26. Our B, we are getting 26, and therefore it is unlocking our E. Because if this is 26, sorry, what is our E? What is our B? What is our E, sorry? So it means our E, we are going to be taking 56 minus 26. This is equivalent to 30. So if our E is 30, then it can be able to unlock all the other values. So this is 30. Then it means our F is 50. Our F is 50. Let us look on our D. Our D should be equivalent to what? Because this is 30. Our D should be 90. Our D should be 90. What about G? In this case, we know our D is 90 here. E and F, we have 80. And then our G should be equivalent to what? 360, right? 360. 360 minus 170. We are getting 190. Then let us now look for our A, because we know our value for B here. Our B already we know is 26. Then it means if I take 196 minus 26, we are going to be getting 170. You can do your summation and you see whether we are getting 250. I start with 240, right? Plus 190. Plus 50, plus 30, plus 90, plus 54, plus 26, plus 170. I'm getting 850. So after I do that calculations, I can now go back to the question and I see the information that, or the requirement that I was told to do, to represent the information in a Venn diagram. Already I have my 5 marks. Then number 2, the examiner is asking the number of residents who own all the 3. All the 3, you can see our E is our O. Because the share is being shared by all the 3 brands. So number 3, it means we are looking on our value for E, which you talk about 30 residents. That is your E. Now, when you look on part 3, the number of residents who own just one of the 3 brands of the vehicles, just one. That is number 3. That is what we discuss about the difference. You see, we have A, we have C, and then we have G. You just say, let's take our A plus C plus G. These are the people who are owning only one. That is what we discuss about the set difference. So A is how much? You say, my A is 170. Our C is 54. Our G is 190, right? So we have 170 plus 54 plus what? 190. This you are getting 414 residents. 419 residents. 419 residents. 414, sorry, residents. I just want to look on a complicated question, which is different from those ones we have done. There is a questions that we have to be checking on. A question they tested on November, a bit different. I will also be doing another one for colleges, because if, for example, you're analyzing your college, they can just explain and you will be able to do it. If, for example, you have represented the information, let us say here is accounting. Here we talk about business students. And here we talk about statistics students. Remember, you cannot be living in an institution without having subscribed to any course. And that is why our age, when you look on the question regarding to the colleges, your age should always be 0. That I think that question you can be able to do it. Because the most criteria, it is always your age should be 0, because you cannot be a member of a school, but you have not subscribed to any course. That is one. Now, I want to look on November 2015. I think they were able to use a different strategy. And I just wanted to, because it is different from the question which they have been tested recently. So it is important I just use that question. You use this one. You can do for the colleges. You let me know. Then thereafter, if, for example, you can be able to present that information to me, showing your working, then I can be able to guide you. November 2015, question number 1. There is question number 1 there, question 1 there. Remember, examiner will never avoid this area. Examiner will not avoid this area. So always be keen on it. Now, let us go to the questions. Let's go to the questions. So 2015, we are talking about November. Question number 1 here. So question 1B, you can see it here. You can read for me. Apex Limited, just go on.
Apex Limited is planning to launch a new product in the market. It has undertaken a survey on the product's color, brand name and packaging. The company sent questionnaires to 200 potential customers to obtain their views on the 3 attributes of the product. The results were as follows. 24% liked the packaging and the brand name. 77 persons liked the brand name or the color, but did not like the packaging. 40% like the color only. 120% like the color or the brand name. 23% like the color and the packaging. 43% like at least two of the 3 attributes. 5% did not like any of the 3 attributes. The questionnaires of 25 persons were not received back. The company's policy is to incorporate an attribute in the product if at least 50% of the respondents like the attribute required. Present the above information in a Venn diagram.
Have you finished?
Oh. 2, number of persons that like all the 3 attributes. 3, proportion of persons that like the color. 4, proportion of persons that like the brand name. 5, proportion of persons that like the packaging. 6, attributes to be incorporated in the product.
Good. Now, when you look at this question, similarly, it is different from what I have done. It is different from what I've already done. So in this case, I just want us to analyze the question. I can see under the note, the last bulletin, the examiner is saying the questionnaires of 25 persons were not received back. So it means you are universal. You take the 200 questionnaires which were done, then you subtract 25 questionnaires which were not analyzed. So they are not inclusive in our data. So it looks like this. Let me go back here. So when I look on that information provided there by the examiner, I can just say, because they are dealing with 3 types of brands, we have color, we have brand name, and then we have packaging. So it will be looking like this. Let me interlock it. It looks like this, right? So based on how they are given, just give in ascending order. We have color here, right? The other one we have brand. And the last one, we have packaging. We have packaging. So it looks like this. So in this case, we talk about universal. So our universal will be, right? Our universal will be 200 minus 25, which were not received. So we are analyzing 175. That is correct. So let us name our empty spaces here. We have our A, B, C, D, E, F. We have our G, and then we have our H there. So it means if I align them here, plus C plus D, plus E plus F plus G plus H should be equal to 175. So what you are going to be getting, we put them here. We have our A, B, our C, our D, our E, our F, our G, and then we have our H there. The total that we are going to be getting should be equivalent to 175. Should be equivalent to 175. Now, let us look on the information provided. We have been told 24% like the packaging and. We say it and it is intersection, right? So 24% like the packaging and the brand name. Packaging and what they are sharing is E plus F, which is equal to 24. Now, we are also talking 77% like the brand name or the color, or we say or is union, right? But did not like the packaging. When I look at it, our kupenda packaging, and when you look on the circle for packaging, you exclude it. So it means it is A plus B plus C. A plus B plus C, examiner is telling us it is 77. So in this scenario, it means packaging is disliked. So it is not factored in the analysis. 40 persons like the color only. Color only, we say it is our A, and our A here is 40. They liked 40. That is a set difference, right? 120 persons like the color or brand name. Color or brand name. Color. All the elements which they are containing there, because we say it is a union, it means it is A plus B plus C plus D plus E plus F, right? Plus F. That is equivalent to 120, right? The other one will be now the other one after 120, we are being told 23 persons like the color and the packaging. When you look on the color and packaging, it means what they are sharing is D and E. We should be equal to 23. The next one will be 43 persons likes at least 2 of the 3. At least 2. And 2, we look on the what they are sharing. At least 2, B is shared, D is shared, E is shared, and F. At least it means 2 and above. So in this case, it means it is B plus D plus E plus F. Those are the ones which are shared, which is equivalent to, the examiner is telling us, it is 43. Now, the other one we have been told 5 persons did not like any of the 3 attributes, and the examiner is giving you your age. The examiner is giving you your age there. So let us analyze our question here. It will be providing us with a good insight. Now, when I look at it, you have A to F. A to F, we have it. Already we know A to F is 120. And then you have your H, which is 5. What is your G? Right? So in this case, you just say 175 minus 125, getting 50. Our G is 50. Do we areas where we have G? Right? We don't have G anywhere. So our G is 50. Now, let us look on breaking it down a bit by checking the values of, let me check here. We have our A to C. Our A to C, we know very well, is 77, right? Then you know very well, you have your D and E, which is 23. So our F should be equal to what? 120 minus 77 minus 23, getting 20. So our F is 20. So anywhere I see F, right? For example, here is 20. D and E, do we have D and E? Yes, our D and E is 23. So it means our B is 0. Our B is 0 because when you take 23 plus 20 minus 43, and the 43 minus that answer, it equates to 0. Now, because I know my B is 0, right? It's very simple here. So our B is 0. Do I have our A? Yes. So our A is 40, E is 0. What is your C? Right? Our C should be 37. Our C should be 37, right? Now, what do we have? What is remaining? I can see is our E. When we unlock our E here, because we know our F is 20, then it means our E is 4, and our D, because here is 4, our D should be 19. That is how simple it is. That is how simple it is. Now, from this scenario, I just now go back to the question. Present the above information. I have already done that. I have 6 marks. The number of persons that like all the 3 attributes. The 3 attributes we said it is our E. That is number 1. Our 3 attributes, our E, which is 4. 4, our 3 residents, who are they? The 4 persons. Now, number 3, the examiner is asking the proportion of persons that like the color. The color, when you look on the color, we talk about A plus B plus D plus E. Now, in this case, our A is 40 plus 0 plus our D, which is 19. Our E is 4. How much it is? So 19 plus 4 plus 40 we are getting 63. You divide by 175 times 100%. What is this proportion? Divide by 175. We get that 6%. Now let us go to part 4. Part 4, the question. And we have been told the proportions of persons that like the brand name. And when I look on the brand name, we have B plus C plus E plus F. So this translates to 0 plus our C, which is 37, plus 4, plus our F, which is 20. So in this case, it means, so we are dealing with 41, 61. 61 over 175 times 100%. So 61 divided by 175 times 100, equivalent to that 5%. Then we go to the last one, not the last one, but number 5, proportion of persons that like the packaging. When I look on the packaging, we have D plus E plus F plus G, which translates to 19 plus 4, right? Plus our F, which is 20 plus 50. This is equal to 19 plus 4, right? Plus 70, equal to 93. 93 you divide by 175 times 100%. So divide here by 175, and this translates to 53%. Then the last requirement we have been told, the attribute to be incorporated in the product. The examiner already has told you that if you want to incorporate any product, this is what he has able to say. The company's policy is to incorporate the attribute in the product if at least 50% of the respondents like the attribute. And that is what you see here. This is that 6, this is that 5. The one that is meeting the requirements is packaging, right? And here we say the packaging is the one that is hitting the target because it has 53. And we have been told if it is able to incorporate, then it has to be meeting at least 50%. And that is why packaging has already done so. Now, that is set theory, done very well. We don't have any other issues to do with it. I told you that the other questions are for college. H should be 0, right? Then you do the analysis the way we have done. Nothing else different there. There is no any other question that is going to be giving you a problem when it deals with set theories. Now, I just want to look on something different under the probability distribution. The probability theory notes I will be able to share with you, right? The probability theory, I'll be able to share that with you, right? So what we are supposed to be looking at, it is the probability distribution. The probability distribution. Now, when you look on the probability distribution here, we have to be looking on because we know very well that when we discuss about the probability, it means we are engaging ourselves to an environment or likelihood whether an event may or may not occur. And in this case, we are saying under certain conditions, probability distribution can be applied. That is, frequency distribution can be used when calculating probabilities. But when you look at it, probability distribution is normally divided into two. One, we normally discuss about discrete probability distribution. Discrete probability distribution. Normally, we have that. Then number 2, we normally have continuous probability distribution. I just want to analyze it very easy. Probability distributions. Then when it comes to the discrete probability distribution, it is normally, these are the distributions, when you look at it, they are distributions that take specific distinct values, right? They normally take specific distinct values. And I just want to break it down for you. Now, in this case, it is also subdivided into 3 here. It's normally subdivided into 3. Let me write it down here. Discrete probability distribution. So we normally have, it is grouped into 3. Number 1, we normally have uniform probability distribution. Uniform probability distribution. 2, we normally have Poisson probability distribution. Poisson probability distribution. Then the other one, number 3, we are going to be having binomial probability distributions. So the first one is not much tested because that distribution, we say that the probability of distribution whereby the chances of occurrence of an event is equal. That is why it is normally called uniform. But when it comes to the binomial, for instance, where it is whereby we say that the results of an experiment here, the results of an experiment, right? The results of an experiment can take only one of the possible outcomes. Only one of the possible outcomes can take only one of the possible outcomes of an experiment, outcomes of the experiment. The most important things the most important thing that you need to be learning about all of this, it is that most probably it might be the assumptions which are basically applicable. Let me put down for you here because they are mostly applicable. So the assumption number 1, we normally assume that there is only one possible outcome. There is only one possible outcome. There is only one possible outcome in an experiment, outcome for each trial. There is only one experiment or possible outcome for each trial. Number 2, we are saying that the experiment the experiment is carried out. The experiment is carried out from infinite populations. It is carried out from infinite population. Number 3, the probability of success. The probability of success, right, of a function. The probability of a success of a function, right, remain constant from trial to trials. Remain constant from trials to trials. They remain constant from trial to trials. Then number 4, which is very important, we say, right, the chances of selecting a defective item, it is dependent of one another there. Then number 5, we talk about the 5th one, which is very crucial, the binomial distribution. The binomial distribution that we are discussing of a random variable is given by, so when you look on the probability of x being equal to r, we normally take n combination r, right? N combination r, we multiply by p, you raise power r, then you multiply by q, n minus r. But what we normally discuss here, p plus q should be equal to 1. What is your p? This is the probability of success. What is my q? This is the probability of failure. Right? So examiners to be giving me, every time I see in a question of binomial, examiners already given me the probability of success. So it means I can be able to get the probability of failure. That is not the problem. What about your R? We talk about N, sorry. Our N, let me put it somewhere here, should be the number of items. Our N should be the number of items. Now, R is the point of target. What are we targeting? We look on the point of intersections there. Now, I just want to look on analysis of Poisson so that I can be able to do 2 questions. I can just do 2 questions as I run away from here. Now, in this case, when you look on the Poisson, right? A Poisson, we are saying it is a discrete probability distribution, that is for sure. that normally describes rare events. It describes rare events in a space of time. In a space of time. It describes a rare events in a space of time. So it is a limit in case of binomial distribution. It is normally described by, right? So to get the probability of X being equal to R, we are going to be taking, in this case, we normally have our average values there, exponential sign, you raise to power, that's a lambda, and then you divide by exponential sign there. R factorial sign. Now, in this case, when you look on this sign, it normally means, right, mean stroke average time. The mean our stroke average time. We have E, which is our exponential sign. It's our exponential sign already found in our calculator. Then we have our R here, our R, which are the number of items. They are the number of items. Then we have this one where we are discussing about factorial sign. That is our factorial sign. I am asking for a minute. I take a call here.
Okay.
When you look on the Poisson, we have already analyzed it in a clear form. Basically these ones you have to be understanding on how to use your calculator very well. So it is not going to be giving us a hard time to be able to solve it. But what you need to be understanding, the two are mostly tested in an exam together with the normal distribution, which is under the continuous probability distributions, which I'll be able to teach you later today. Now, in this case, I just wanted to look on illustrations, which will be able to assist us to come out of this. I just want to look on one question here. One question tested on May 2017, question 2B. May 2017. May 2017, question 2B. May 2017, question 2B. So May 2017, where are you? So it's almost here. May 2017 here. So May 2017, where are you? Can you see QS somewhere? Yes, is here. Question 2B. You can read Viwanda, and you can see the examiner is asking you, number one, to highlight 4 properties of binomial experiment. I was able to write you here the properties, which are our assumptions also. So let us go to Viwanda.
Viwanda Limited is a company that operates in the printing industry. The company has a total of 30 machines that operates a 24-hour cycle. The probability of a machine breaking down on any given day is 0.015 required. The probability that exactly 4 machines break down in a given day using Poisson distribution. 2, the probability that exactly 4 machines break down in a given day using binomial distribution. 3, comment on the result obtained in B1 and B2 above.
Now, very good. It is a good question when you look at it, because the examiner was able to tell you the company has a total of 30 machines that operate a 24-hour cycle. So the probability of machine breaking down is 0.05. And you can see the examiner already has given you the probability of success, which is 0.015. So in this case, right, we look on right. In this case, we look on binomial probability distribution, where we said to get the probability of x which is equal to 4, because we have been told it is 4, our r, it should be equal to n combination r times p u raised to power r times q n minus r, right? Now in this case, we know very well 30, when you look on n, examiner has given you n as 30, right? Our r is equal to 4, right? The probability of success we have been given 0.015, then the probability of failure, it will be 1 minus 0.015, right? Which will be equal to what? 1 minus 0.015, we get 0.985, right? Now, in this case, we can be able to do our question by saying P of x being r, right, should be equal to 30, combination 4, times our P now, which is 0.015, u raised to power r, which is 4, times our 0.985, which is the probability of failure, n, which is 30, minus 4. So how much are we getting here? I can see, as you can see as per my calculator here, here it has n combination r here. So directly we'll be able to press to get our C. So I just say 30. When you look at it, I just say, let us take our 30 combination, because I have it. It is n combination r. This one, it is already displaced in your calculator. So I just press that button, combination 4, right? Times 0.015, right? You raised to power 4 times 0.985, you raised to power 26, because that minus 4 is 26. You raised to power 26. I can see what I'm getting now. I'm getting 0.001. That is what I'm getting. 0.001. I can see, yes, it is. This is what I'm getting here for binomial. Number 2, we talk about Poisson probability distribution. Poisson probability distribution. And I think we were able to say the probability of x being equal to r, we say we take our mean, you raised to power r, then you multiply by exponential raised to power negative mean, then you divide by r factorial. So in this case, we say our p of x being equal to 4 should be equal to, we don't have our mean. And then when we don't have our mean, you just take n times p. Our n is 30, our p is 0.015, right? So 30 times 0.015, we get 0.45. So here just say 0.45, I raised to power r, which is 4, times exponential, you raised to power negative 0.45, then you divide by 4 factorial. All of these figures or these values are existing in your calculator. Now, exponential sign, you remember, you can see there is a button written like that. That is a natural log. So if I can be able to press shift and that button now, right? Not shift, but alpha. It will be alpha this. So alpha in. So alpha natural log. We get a bold E. Then you raise to power negative 0.45. A minute, please. There might be a challenge somewhere. So we were discussing about getting the solution here, right? And I have said, when you press your alpha in, you are going to be getting a bold E, then you raise to power negative 45 or 0.45, sorry. That is equivalent to 0.63. Then we multiply by this one times 0.45 raised by 4. Then we divide by 4 factorial. To get this factorial, we just press shift. Just press shift. Then there is a button in your calculator written as x raised to power negative 1. Raised to power negative 1. There is a button looking like that. So press shift and that button. you're going to be getting this factorial sign and then equal sign, right? So in this case, we are going to be getting our answer as 0.0011. That is the answer that we have gotten there. That is the answer that we are going to be getting there. So that is how you normally calculate between the two. That is what you normally calculate between the two. Now, when you look on the differences, you see that the answer for this and this one, you look on the one which raises a higher chances of occurrence. And we say, in this scenario, we say Poisson raises a higher chances. Poisson raises higher chances of occurrence. Higher chances of occurrence. It raises higher chances of occurrence. Compared to binomial distribution, and you look at it because it has a highest proportion compared to this one, right? So that is where you say it applies in a concept where one is going to be raising a higher chances of occurrence compared with the other. That is what we see. We are trying to agree on that ground. We are going to be agreeing on that ground. Now, before we go to continuous probability distribution, I just wanted to look on our previous 2 semesters where they were able to bring these kind of questions. Let me look here. Let me look on our last 2 semesters, whether they were able to bring the 2 concepts. That is in 2022. So let me start with August. So August is here. Let's see whether they were able to bring any of these concepts so that we can deal with it. Good. They were able to bring the normal distribution. So the normal distribution is existing there. We shall be able to do it. But I can see in question number 7, you can read it. Question 7 now.
A technician at Light Industry Limited has established that the probability of a production process producing defective output is 0.2. A total of 60 units are produced from the process in a certain production period required. The probability that exactly 10 of the units will be defective, assuming a Poisson distribution. The probability that exactly 10 of the units will be defective, assuming a binomial distribution. 3, the expected number and standard deviation of units expected to be defective, assuming a binomial distribution.
The last one we shall be able to deal with it later. But first, I just need to do the first two requirements. And when I look on those first 2 requirements, the examiner is asking us to compute binomial, right? To compute your binomial distribution and also Poisson. Now, in this case, let us go back to our board here. So in this case, we are being told here to calculate, because already it is being defined there. We just need number 1 to calculate your Poisson probability distribution. And we have said, first, let us write our formula, right? We should be equal to our mean, you raised for R, exponential rate for our mean, then you divide by R factorial. So it means to get our mean, in this scenario, we take N times P. The examiner has given you 60 times 0.2. This is equivalent to 1.2. Is it 1.2 or 12? Should be 12, if I'm not wrong. So our mean is 12. Then our R, we are being given exact 10. So it will be P of X be equal to 10. We should be equal to, we are being given 12, you raised power 10, times exponential, you raised power negative 12. Then you divide by R factorial. Our R is 10 factorial. 10 factorial. Now in this case, we have to be taking 12 you raised, sorry, we start with the exponential. We said alpha, we have our natural log button, we press it, it gives you the board E, you raised power negative 12, right, getting that figure there, times 12, you raised power 10, getting that figure there, then you divide by 10 factorial. 10 factorial, so shift alpha. So we are getting 0.1048. We are getting 0.1048. Then when you go to number 2, we are talking about binomial probability distribution. Binomial probability distribution. In this scenario, it is very simple since we say the probability of X being equal to R should be equal to N combination R. You multiply by P, you raise to power R, then we have Q, N minus R. Remember, we said our N is 60. As per the question, we multiply by, 60 combination 10, because the examiner is asking 10. We multiply by the probability of success examiner was able to give you 0.2. You raised to power 10 times our Q, which is 0.8 now. You raised to power 10 minus 60 minus 10, 60 minus 10. How much am I getting there? We said we take 60. You press N combination add button in your calculator. 60 combination 10 times 0.2, you raise to power 10 times 0.8, you raise to power 50. I'm getting 0.1102. 1102. Have we understood?
Yes.
Have you understood?
Yes.
Very good. So Eunice, what we need now to be able to do, I just want to do another model, which is mostly tested, and you can see even in August 2022 was applicable. When you look on the continuous, because we say probability distribution is subdivided into two, discrete, with that one we have already done. Then we have, we talked about the continuous probability distribution. So the most important thing here is to look on continuous probability what? Distribution. Continuous probability distribution here. It is subdivided into, we also have uniform probability distribution. Uniform probability distribution there. We normally have uniform, not uniform, but normal probability distribution. This is the one that is mostly used and most tested. And then the last one, we are discussing about exponential probability distribution. So the two I will not be able to teach you. They are never tested. So let us focus our attention to our normal probability distribution. It is the most powerful and most used model. Even you can see as you continue looking on finalizing your CPA, you will be able to learn much about the normal distribution, probability distribution, which is mostly applicable in most of these syllabus, custom syllabus. Now, that is why we are saying it is the most. It is the most used distribution. It is the most used distribution. And in this case, it is used to describe many business phenomena, such as length, height, weight, or volume. So it is a limiting case of binomial distribution where the number of data values is very large. But it is normally described by, it is basically described by, right? We normally talk about the z-score, which is x minus u, you divide by the standard deviation. Z minus u, you divide by the standard deviation. And you know very well where we are saying this is the z-score from the table, right? We have our x, this is the point away from the mean, the point away from the mean. We have our u, this is our mean now. And then this one is our standard deviation. This is our standard deviation there. Now, in this case, there are some of the properties or characteristics of, we normally look on the characteristics or properties of binomial distribution, or not binomial, but normal distribution, characteristics, stroke properties, very commonly used when you are solving the normal distribution questions. So number one, if we know very well it is a continuous probability distribution, remind the examiner that it is a continuous probability distribution. Number two, here we are saying that the area under the curve is equal to 1. The area under the curve is equal to 1, right? Number three, we normally look on it is symmetrical about the mean. It is symmetrical about the mean. It is symmetrical about the mean. Now, number four, it is completely defined. It is completely defined when the mean and standard deviation is completely defined when the mean and standard deviation are given. It is completely defined when the two are given there. Now, it means the mean is equal to the median. In case the examiner is asking those kind of questions, you say the mean is equal to mod and median. So when you look on the question, I just want to start by looking on these questions. I start by doing that in 2022 April. There is a question there. So let us start by doing that question here. There is that question somewhere, right? Question 6. Question 6B. Question 6B. Can you read for me, please?
The weights of 1,000 items are normally distributed with a mean weight of 200 kgs and a standard deviation of 22 kgs. Required, determine the number of items that have weights between 210 kgs and 220 kgs. 2, determine the number of items that have weights between 180 kgs and 230 kgs. 3, calculate the weight below which 20% of the items fall.
Now, very good. The examiner has already given us a good question there. And he has given us a good problem that we can be able to solve. Now, when I look at it, we have said one of the properties of the normal distribution, right? One of the properties is that it is completely defined when the mean and standard deviations are given. That is what we have discussed about it here. So let us look whether the examiner was able to give our mean and whether he was able to give our standard deviation. So when I look at it, when I look at it here, our mean, examiner was said, the weight of 1,000 items are normally distributed with 200 kgs. That this is 200 kgs, which is our mean. And also you say, and a standard deviation of 22 kgs. Very simple. Now, remember, you are going to be drawing your normal curve, right, to analyze. So we start with the first requirement. The examiner is asking us between 2 points. So we draw our graph looking like this, and the normal curve, sorry. Then our mean here, our mean is equivalent to how much? We have talked about 200, sorry. Then here, our standard deviation is equal to 22. So let us look on the requirement. What is the examiner is asking? Is asking to determine the number of items that have a weight between 210. The 210 is above here, right? So it is between somewhere here. The 210, it is here, right? This is a point away from the mean number 1. And then we are being told it is between the 2. So between 210 and 220. 210 and 220. Looks like that. So the examiner wants the here. That is the area the examiner needs. So in this case, right? In this case, because the examiner seems to be very wise, what we can be able, the power that we have is to get from that point to that point, because we have 200 and 210. And then we also have the power to get from here to here. Then the difference will be this area is requesting for. Now, the first one we say, because we say to use our z-score, we take x minus u, you divide it by the standard deviation. Our x, we have talked about it being 210 minus 200, you divide by the standard deviation of 22. How much is this? 10 divided by 22. 10 divided by 22. I'm getting 0.45. Hii tunaenda tunasoma from table. We are going to be reading it from the table. Now in this scenario, because we are reading it from the table, let us look here whether the examiner was able to provide the normal distribution table. I can see it is not there. So let me look for it. The normal distribution table. Let me look for it here. Let me look which, let me just search it. The normal distribution table so that we can be able to use it. The normal distribution table. The normal distribution table. You can see the table is here. And then what we were able to get, 0.4. When you look at it here, we have 0.4 here. Then you match it with your 5 up there. So your 5, I can see, examiner is giving us 0.1736. That is what we can be able to get from the table. We have talked about 0.1736. I see now you can be able to read it from your table. That is how we normally read. Because already the table normally comes when the examiner has given you the Z values. Then you match with the respective values. So you take the first decimal point, which is 0.4. Then you match with 5. We match with 5. That is why we are getting 0.1736. That one. Now, from that point, let us get back to our board. So after getting this, we just leave it from there. Let us get the second one. We are getting 220 minus 200. We divide by 22. So this means we are taking 20 divided by 22. 20 divided by 22, getting 0.91. So let me go back to my table and I look where 0.91 lies. Right, 0.91, 0.91. We are getting 0.31. You can see it is here. 0.3186. 0.3186. 0.31. .3186. So to get the area that the examiner wants, to get that area under consideration, we just say, because already I have gotten this as 0.1736, and this one we have gotten as 0.3186. You just subtract between the two. So 0.3186 minus 0.1736. How much am I getting there? 0.3186 minus 0.1736. We are getting 0.1450. 0.1450. Now, from that ground, let us proceed by looking at the second requirement, where the examiner is asking also is asking you to do certain things here. The examiner is telling you to do. The examiner is telling us to do what? Right? Let me see. Determine the number of items that the weights are between 180 and 230. Very simple. So you draw your normal distribution curve. I know that you are seeing my board. The normal distribution curve there. So the normal distribution curve, we start by drawing our mean. Then here our standard deviation is 22. So we are discussing between 180, which falls here. X is 180. Then the other one, we are being told between 180 and 230. 230 falls here. So the examiner wants the shaded region here. This is very simple because it's just an addition. So I will say, let me take 180, which is my X, minus 200, divide by 22, plus 230 minus 200, you divide by 222, right? So let me start with the first one, 180 minus 200, which is 20, divided by 22. I will be able to get 0.91. We ignore the negatives. So the other one will be 30 divided by 22, getting 1.36. Then these ones you go and you look from the table. Don't add them at this stage from table. Don't add them from that point. Then in this case, 0.91, I see we were able to get it somewhere, which we got 0.3186 plus. Now, how much is 1.36? Let me go back to my table. So let me go back to my table here, right? So our table shows us. Can you see it?
No.
Okay. Higher. One, we have discussed about 1.36. 1.3 here. Then you run to 6, where the 6 falls. 0.4131. 0.4131. 0.4131. So let us go back to our board now. So it looks like this. So now you can be able to add your probabilities. I just say, let me take 0.3186 plus 0.4131. We are getting 0.7317. 0.7317. 0.7317. That is the solution I was able, you can be able to sort out that problem. Now, when you look on the third requirement, that requirement there, the examiner is asking us to do what? Let me check. The examiner is asking you to calculate the weight below which, right? And the examiner was, by the way, asking us to determine the numbers. So I can see the weights of 100 items. So it means straight away, you just need to be multiplying here with 1,000 to determine the numbers. So this is equivalent to 731 items. The other one here will be, if we multiply this one by 1,000, because we have been told to determine, he is not asking for the probability, but he's asking for the items. I can see this is 145. It 145 items? Should be something like that. It should be something like that. Something like that. Because 1450, let me check. 0.145. That is okay times 1,000. 145 items. I can see it is okay there. Calculate the weight below which 20% of the items fall. Now, in this case, the examiner has already given you 20%, 0.2. That is your, right? Examiner has already given you your Z value. So it is very simple. So this is how you determine it. So it looks like this, right? Our mean we know very well, it is 200. Our standard deviation here, we know it is 22. Now, the point away from the mean, whether it is false on this side or the other side, we don't know. So we say our Z square is equals to X minus U. We divide by standard deviation. We divide by the standard deviation. We divide by the standard deviation. Now, in this case, examiner has given us 20%. 20%, which is equivalent to 0.2. 0.2. Now, in this case, once you get the 0.2, it's our Z value. So you say 0.2 is equals to our X, which we don't know, minus 200. You divide by the standard deviation of 22, right? So this you multiply by this one, you just cross multiply. It will be 0.2 times 22 is equals to X minus 200, right? So in this case, 0.2 times 22. This is 4.4. We should be equal to X minus 200. Take this on the other side. And then we are going to be having 4.4 plus 200 is equals to X. Our X should be equal to 204.4. Our X should be 204.4. That is the weight that we are looking for, 2.4 kgs. Have you understood?
Yes.
Good. Now, I can do another question for you. Let us look for December 2017. There is a good question there before we get out of these probability issues. So let us look on December 2017. There is a good question there. This is December, November. Let me look on how the questions are written. Question number 2C. Can you see it?
2C.
Yes. You can read.
Okay, a survey conducted on citizens of a certain country to determine the annual per capita income indicated that the annual income of the citizens is normally distributed with a mean of shillings 980,000 and a standard deviation of shillings 160,000. One citizen was randomly selected from the country. Required the probability that the annual income of the citizen, 1, is greater than 500,000, 2 is greater than 1,220,000, 3 lies between shillings 852,000 and 1,100,000.
Good. So what you need to be understanding, by the way, when you are doing regression, you cannot miss a question you cannot miss a question of probability distribution in any. You can't. That exam can't be complete. That is one thing that you need to know. Now, let me check on this question very quickly before I do for you a question of confidence interval, which is basically is another area where the student needs to master and understand. It is December, yes. So I just come here. Go back to my board, right? So I just say the question is December 2017. Question number 2 should be 2C, yes, 2C. So the examiner is telling us to use a normal distribution knowledge. to be able to sort out this problem. He has given you the mean of 980,000. 980,000 and our standard deviation, which equivalent to 160,000. 160,000, right? Now, in this case, you see, between the two, you just come and you take the examiner. This is the formula which I normally use. So, and I cannot be able to solve any question of the normal distribution without the use of the normal curve. So you just use your normal curve there. So you know very well your mean is equals to 980,000. My standard deviation here should be equal to 160,000. Now the examiner is talking about it is greater than 500,000. 500,000 lies here. So when you look on the number line, X is here, 500,000. So it should be greater. So it means the only power you have, it is from here to here, right? And then we say the area under the curve is equal to 1. So we know here is 0.5. So this is the area needed. So let us get this point so that we can add our 0.5. It will be looking like this. 500,000, which is our X, minus 980,000, you divide by 160,000. 160,000. So this is how it looks like. So 500,000, and I said you normally ignore the negatives. You divide by 160,000. This we are going to be getting 3. Go and read from table. From the table, what is the probability given there? So that is 3. So in this case, I go to this table of mine. I check where the 3 is, right? Where the 3 is. So let me check with you. So our 3 is here, right? 3.00. This is the 0.00 here. We should be equal to 0.4987, right? 87 there. Now, let me go back to my board because I know now you know how to check that. So 0.4987. But the examiner is asking the greater. So it means the 0.49 falls here. 87. That is where it falls. So in this scenario, we just say, let me take 0.4987 plus 0.5. And you are going to be getting 0.9987. 0.9987 there. That is how you do it. Now, let us look on the next requirement. The next requirement, the examiner is asking what? The next requirement there. Examiner is asking us, it is greater than 220. I just need to draw the normal curve to make it easier for me to make analysis. 220. Our mean, we know very well, is 980. Here, our standard deviation is 160,000. When you look on the number line, 220 lies here. 1220, sorry. That is our X. So it means here, this is the only area you need. That is the area you need. But ile nguvu uko nayo ni ya kutafuta kutoka hapa hadi hapa. So unasema, and then najua kutoka hapa mpaka hapa mwisho ni 0.5. To get here, I just need to take 0.5 times the probability that I'm going to be getting for this area. So it is 1220,000 minus 980,000. You divide by 160. 160. So 1220,000 minus 980,000 divided by 160,000. You get 1.5. Kimbia kwa table and you look 1.5 from the table. 1.5 from the table. So when I look on the 1.5 from the table, it reads 1.50. 0.4332. Right? So to get a shaded region, I just need to take 0.5 minus 0.4332. So how much am I getting there? 0.5 minus 0.4332. We are getting 0.0668. 0.0668. 0.0668. Are we okay up to that point?
Yes.
Let us look on the last requirement. It lies between 852 to 1100,000, and it looks like this, right? So your mean here, it is 980. Our standard deviation here will be equivalent to 160,000. So it falls between what and what? We are talking about 852, which is here. And the last one, our X, which is on the other side, we are given 1100,000. So the area we need, it is this area. This is what we need. That is what we need. That is what you need there. So to get that area, very simple here. To get that area, we just say, let me take 852,000, which is the point away from the mean, minus 980,000. We divide by, right, our mean, which is our standard deviation 160, plus, right? Now, the other one will be 1100,000 minus 980,000. You divide by the standard deviation, which is 160,000 there. Now, in this case, we say, right, let me take 852 minus 980. You divide by 160, and I'm getting here 0.8 plus the other one will be 1100 minus 980, right? Divide by 160. Getting 0.75. And uangalia kwa table, the 2. So 0.5, 0.8, sorry, is giving you, from the table when you read it, 0.2881. Then when you look on 0.75, right, it is giving you 0.2737. 0.2734, sorry, it should be 4 here. So in this case, you just say 0.2881 plus 0.2734. I'm getting 0.5651. Assignment now. Assignment. Just look on May 2016. May 2016, we have a good question also there. Question 2B. Question 2B. Look for that question there. You do. Even I think when you look on the April law 2021, all of it, you can't miss a question of the probability distribution. You can't miss these questions. Now, I just want to do something different very quickly before we start our first break. Before we serve our first break. Now, we are looking on a confidence interval. We are looking on the confidence interval. And when you look on the confidence interval, we are saying, when you look on this confidence interval, I know already a confidence interval represents the units of range, right? It represents a unit or a range within which the data values which are predicted must fall within. And that is where you see, I normally hear ladies saying, I need to marry between a man, between 26 to 30, 45, and so on. That is the area they have confidence, sacrificing their love to the people they want to do so. So that is where we look on the confidence in that. It will be able to represent the unit or a range within which the data values will be able to fall within. So it will be showing us, you say here, it shows the upper and the lower limits. It shows the lower and the upper limits in a given point estimate. So it means we are going to be having 2 points in a given point estimate. In a given point estimate there. So the estimate will therefore mean the expected value. Intervals can be constructed using the z-score or the t-statistics, right? So we can be able to construct the confidence intervals using the z-score or t-statistics, right? This means the difference between the two is just about the population. So you see, for Z statistics, we either use, sorry, we just say this, let me put it in simpler way. We say, if the sample size is small, if the sample size is small, that is less than 30, right? If the sample size is less than 30, then we use Z statistics. We use Z statistics, right? We should be using T. Sorry, we use the T statistics. If the sample size is greater than 30, we use Z-score. We use Z-score there. But if, right, if the population variance or standard deviation, if the sample size, if the population variance or the standard deviation is known, irrespective of the sample size, we use Z-score. Never forget that. So this is very crucial. That is very crucial. If the population variance or the standard deviation is known, irrespective of the sample sizes, then we are going to be using the Z-score there. Now, in this case, you have to be asking yourself, how do I normally get the confidence interval here? We normally take the point estimate plus or minus. We are discussing about using Z or T. Then we multiply by the standard deviation over the root of n. This is different from what you are going to be learning from regression. It's different. So now you get the confidence interval. Now, you remember very well, PE is the point estimates, right? The point estimates. Then we have our Z, which is Z-score. Is our Z-score. We have our T, which is we normally talk about T statistics. Is found in our tables. We have T statistics. We have this sign which we are using here, meaning for standard deviation. Then we have our N, which is our sample size, stroke, right? Sample size. Or we can talk about the number of items. The number of items there. The number of items. Now, let us go to May 2018 question 2C. Right? So let us go there. May 2018 question 2C. Very quickly there. So let me see where we are. May 2018. May 2018, all right. You are talking about question 2C. Can you read the question?
You can see the question.
Okay, let me share. Mwanaisha, it is C.
Mwanaisha Ali sells 3 seedlings at Mavuno Market. A random sample of 9 of the seedlings had the following height in centimeters. We have 64, 62, 65, 63, 68, 69, 65, 63, 65. Required 95% confidence interval of the population mean height of the seedlings.
Very good. When I look on this question, we are being told a 95%. What I cannot see there is about the standard deviation. It is not provided, but you can be able to look for it. Number two, when I look on it, on my question, I can see a random sample of 9. So it means I have to use t-statistics. I have to use the t-statistics. So because the sample size is less than 30. So in this case, this is what you do. You tell me the examiner has not provided the standard deviation, which does not have any problem, because the confidence interval, we normally take the point of estimates plus or minus, because we have said now, we have settled by using t, the sample size is less than 30. Then we multiply by the standard deviation over the root of n. You tell me the standard deviation is not used, is not given, which you say it is not a problem. We take the summation of x minus our x bar, which is our mean, squared, right? Right? Then we divide by, because the sample size is less than 30, you divide by n minus 1. If it was greater than 30, you divide by n alone. Let me repeat again. If you are calculating the standard deviation and the sample size was greater than 30, you divide by n only. But if it is less than 30, you divide by n minus 1. I think that is clear. So let us look at our x there. Our x is given. Examiner was able to give you a x there. So we are being given 64, 62, 65, right? 64, 62, 65, 63, 68, right? We have 69, 65, 69, 65, 63, 65. What is the total of your x here? What is the total of your x? The total of my x is 584. How many are they? They are 9. What is my x bar, right? What is my x bar there? So let me take my calculator down here. 584 divided by 9. We are getting 65. Can I use 65? Yes. Let me just use the whole number. So my x bar here will be 65, 65, 65. See, it is looking like this. So what about my x minus x bar squared? So this is 1, squared is 1. This is how much? 3, 9. This is how much? 0. This is 2, 4. This is 3, right? 9. This one is how much? Is it 4? 16. This is 0. This is 2, 4. And this is 0. How much am I getting here? So 10. 10 plus 4, 14. 14 plus 9. Right? Plus 16. Plus 4. I'm getting around 43. I'm getting 43 here. So let me get my standard deviation by taking the root of 43 divided by 9 minus 1. So it means it is divided by 8. The root of my answer will be equivalent to 2.32. That is my standard deviation, 2.32. Now, to analyze our scenario, because we don't have the t-statistics, to analyze it, you just use the normal curve. right? The normal curve. The examiner has given us a confidence interval of 95%, leaving 5% falling on the tails here. 5% falls on these tails of yours. So in this case, when you take 5%, you divide by 2, you are going to be getting 2.5%. This is equivalent to 0.025. And also here, 0.025, right? So if we need to get the t, you need to be taking 95, you incorporate a single tail, one tail. So it will be 0.95 plus 0.025, getting 0.975. This one, you compare, you check, you match it with the DF, the degree of freedom, right? The degree of freedom is the term you're going to be hearing when we are going to be doing our regression. So our degree of freedom, we normally take n minus k. In our case here, right, we take n minus 1. So it is 9 minus 1, which we are getting 8. Let us go to the table and we read this from table. Right? Let us read that from the table. Let me Google 4. Let me check whether the examiner is providing here. Right, it is not also, it is there, yes. The T table, you can see it. So let me share it. Let me share it here. So the T table normally looks like this. When you look up here, you can T250, 275 namna here. We are looking on T975 here. So we are matching it, right? We are matching it with our 8. You see our 8 here? So we are matching with that T975. And you are getting 2.306. 2.306. 2.306. That is how you get your T. Let us go back to our board here. Now from there, because I have already gotten my T, this is my T now, right? Let me say, to get my confidence interval, I'm going to be taking the point of estimates, right? Our point of estimates, right? PE. PE, it means this one basically you use your mean. So our mean is 65. Plus or minus, our T is 2.306. We multiply by the standard deviation. Our standard deviation, you are able to get is 2.32. You divide by the root of 9. Because our n is 9. So it means we are going to be having an upper limit and lower limit. So upper limit will be 65 plus 2.306 times 2.32, you divide by 3. Then the last one will be 65 minus 2.306 times 2.32, you divide by 3. So let us get answers for both. So let me start with the first one. 2.32, you divide by 3, right? Times 2.306 plus 65. We are getting 66.78 here. Then let us look on the lower limit. 2.32 divided by 3. We multiply by 2.306, right? Then we take 65 minus my answer. I'm getting 63.22. 63.22. That is how you get the upper and the lower limits. The upper and the lower limit. The upper and the lower limit. The upper and the lower limit. That is how you get it. That is how you get it. And the probability is done. The probability is done and dusted. So, how many minutes do you want me to give you a break?
30.
30 minutes. Very good.
Yes.
30 minutes are enough. We come back, we do regression and correlation analysis. I just want to finish it so that we remain now with small topics. We remain with small topics. So we can break, then we shall come back and we do regression and correlation analysis. Thank you.
Okay.